Hi, welcome. Thanks for joining the talk here. Going to talk a little bit today about application security and risk-based models. My name is Zak Wolff. I'm a senior solutions engineer with ThreatX. So as a starting point, the first thing we'll kind of look into here is we're going to talk a little bit through how previous types of web application firewalls and WAF technology is failing. And we're going to kind of talk about the risk-based approach that ThreatX has taken. And from there, then we'll jump in and do a kind of a demonstration, look into the product itself and see exactly how that plays out when you're looking at actual requests and responses. So really the good stuff. So a couple slides first. On the front side here, when we're talking about application security, right? We've got there's a pretty well known stigma in the industry around application security and essentially the older traditional models, right? And so with the traditional models, there's a lot of different reasons that people are frustrated with those. A lot of management overhead. Generally speaking, they don't cover the full array of different types of threats these days that folks are interested in detecting. So when we're talking about bots, DDoS, a lot of those things are bolted on, right? Additionally, now there's a focus on API and other types of applications beyond just standard web apps. So essentially, what we don't want to do here is bolt all these features on together, right? A lot of the traditional products, again, are this host of different features that have been bolted on over the years. Very cumbersome to manage, very difficult, and really ultimately to really make things worse, what sort of happens is you get this intelligence or these alerts and alarms, and then they send you off elsewhere to try and manage those and understand what's happening in your WAF tool. So ThreatX has taken a fundamentally different approach, and we're going to talk a little bit about what that is and how it looks here. That is going to be a risk-based approach. So instead of essentially making binary decisions at a very simple level, what we're doing is looking at a host of different metadata, correlating that up together for you, and combining these into an attacker-centric perspective. So what are the benefits of focusing on risk? One thing from a high level that's important is that we can quantify, the overall potential for loss and negative impact, right? So you can, again, align those higher level security goals with the business and application goals. So that's kind of more of the high end side of things. When we dig down into the actual specifics and the technology side of things, you get the ability to integrate different detection strategies. You can take in context over time. So ThreatX is actually looking at a rolling 90-day window of this attacker-centric perspective. And what this ultimately allows us to do is achieve a much lower rate of false positives than you're going to see with other application security technologies. Okay, so the bigger picture, right? How are we doing this? Kind of what are the elements that we combine, and what different strategies go into this risk-based detection model? So we've got application behavior profiling, right? That's one way that we're going to be looking at it. Different metadata we're collecting, understanding, and learning about the behaviors. So we're actually going to profile those different applications. Additionally, we are doing fingerprinting and tracking. So you're going to see different ways that we're understanding who is behind those different requests, right? Maybe it's fingerprints via TLS, maybe it's browser fingerprinting. There's different ways and at different times that these are taken, right? It's not just as simple as, hey, every request, we take all these fingerprints and look at them. It's really clever as these different entities, as we call them, are interacting with the platform or your web applications. We're going to be, at different times taking these different fingerprints, correlating those together in an automated way, and that's going to allow you to, more effectively understand who's behind these different, correlating those entities together, essentially. Okay, so how do we take these different correlations and turn them into value, right? So what are the different ways that we're going to collect this metadata, piece it all together and correlate it, and then what is that going to do for you, someone tasked with securing these applications, right? So by taking, from a very high level, it's easy to explain because we take a lot more information into account. We're able to make better decisions, about what should and shouldn't be blocked, what is allowed, and how to react to these different entities. The real full spectrum of ThreatX's detection methodology is anchored around the kill chain. So you guys are probably familiar with the concept of the kill chain and different ways that you can understand attacks and perspective of the kill chain. You can see in the slide here, we start with the reconnaissance, move to scanning and mapping. Now, one of the things that's really interesting about ThreatX's approach is that a lot of the traditional technologies out there, when you look at some of these lower level stages in the kill chain, that information is generally thrown out, right? There's usually what I've seen one of two routes. Either you're going to throw out that reconnaissance and that scanning altogether, or you're going to alarm and alert on it. You're going to notify somebody every time. So both of those approaches really don't play out very well in real life, right? Dropping the information altogether, you're missing key information, and we'll look at more about why that is. But if someone is scanning or performing reconnaissance against your application, most likely they are also then planning to work their way up the kill chain into higher levels of the attack or higher levels of the kill chain, more advanced components of the attack, right? That's ultimately what they're looking to do. So what we do at ThreatX is we're going to actually keep that information as they move up the kill chain. We're going to correlate these entities together for you. So if someone scanned your application a few days ago, now they're doing some mapping today, we're going to slowly bump that risk score. And we'll actually look at in the demonstration the specifics of that. But this is a very important part. So the algorithm that we've developed to sort of work our way through the kill chain and assess risk is kind of keyed on this 1 to 100 scale. So as these different entities interact with your applications, your APIs, we're going to be monitoring those and looking at assigning these different risk scores based on those behaviors. Once a threshold of 70 is reached, that's when we're actually going to auto block that particular entity. We're going to do that for 30 minutes. They're going to be blocked. Then we're going to reduce that risk score. They're going to be allowed to interact again. So we're sort of playing a game of cat and mouse with the attacker. This is all automated by HackerMind, and that is a huge part of how we're able to reduce the amount of work overhead for the analysts and those tasked with actually securing apps day to day. So essentially, what we can do is, from the highest of levels, again, over time, by calculating and tracking these risk scores, we're able to focus down on the most important attackers that you need to look at on any given day, right? So whether it's someone that started scanning a few weeks ago, moved into exploitation, things like that, whether somebody jumps right in and begins attempting SQLi, cross-site scripting, we're going to be able to track those entities for you and show you them in a meaningful way. So I think, again, slides, not super into spending too much time on the slides. What we're going to do now is jump into a demonstration of the product, and I'm going to show you specifically the kind of visibility that we give you into these attacker-centric entities based on this risk modeling approach. All right, so let's take a look now kind of into the ThreatX product itself. I really think that it's going to do a better job of showing you how this risk-based modeling approach works, kind of looking more under the hood at the actual specifics. Before we jump in, though, there's a couple points that I want to make that help really set the stage. And that's kind of understanding how ThreatX, is integrated into an environment. So as a cloud native platform, we do sit in line as a reverse proxy. So we're going to be doing full TLS decryption That's 1.2, even 1.3 as well. So we're kind of primed for that full visibility into your application stack. Now, you can deploy ThreatX into public or private clouds, but we do have our own ThreatX cloud that most customers use. So just kind of wanted to set the stage there so you can understand where ThreatX integrates into your environment and how that works. Now, one of the nice parts about being cloud native is that we have a lot of flexibility on where we can sit. So if you want us to sit before your load balancers, after load balancers, if you need us on premise, if you need us in your cloud, we have a lot of flexibility, and it's really easy to drop us in line in those different scenarios. So, furthermore, ThreatX out of the box does support some of the web application technologies that might traditionally give issues to this type of technology, like WebSockets, for example. So just in case you're wondering, that those technologies are supported out of the box. So we're sitting in line, reverse proxy, doing full TLS decryption. Now, we're also doing some global server load balancing on the front side, right? So these ThreatX sensors, these reverse proxies we're running, we're also able to auto scale those. So in the event that we see bursts, large bursts of traffic, whether that's malicious via DDoS or intentional, via a nice healthy burst in traffic, we are going to be able to auto scale those sensors up to handle that load. Now, when it comes down to latency, that's always a concern as well. So I just like to briefly mention, we shoot for 40 milliseconds or less. What we tend to see in production is actually closer to 10 or 15 seconds, milliseconds of latency is added by incorporating ThreatX. So extremely low levels of latency allows us to very efficiently, block these different types of attacks. Ultimately, what that really leads to is the ability to rapidly integrate ThreatX into your environment and kind of a fast route into blocking mode. So I've already kind of done some comparisons and contrasts with the legacy technology. A lot of what we do at ThreatX is initially is centered around kind of shifting the mentality about how you look at web application security. And that is really, you can see it at various elements from the risk-based modeling approach here, all the way down into things like how we are going to be able to, integrate directly in less than 48 hours, right? The ThreatX learning mode is 24 to 48 hours is what we typically see. So very different from a lot of those other technologies out there. And when we dig here into the risk-based model, hacker mind as we call it, you're going to see and kind of understand more about how that works. So you can see here we're looking at the ThreatX dashboard. There's a couple main views that we can cruise through. The Explorer-based view is actually going to be looking at larger past historical time frames. So here's for example the last 7 days. Over here in the live view, we're going to get smaller slices of more recent data. So again, remember that ThreatX gives you 90 days worth of historical data is as we're tracking these different attackers, right? So different views kind of depending on what it is you're interested in looking at the time. Now, the really interesting part about ThreatX, kind of what this is all building up to, is this behavioral-based risk modeling. So high level, what we're going to do is we're actively modeling the risk of application users, or entities as we call them. You can see them here in the center. And this is going to be done via a number of different techniques, but the easiest way to think about it is really that this is a kind of a really clever fuzzy logic engine. Right? So we're incorporating third-party intelligence. We have behavioral rules, there's heuristics, all the metadata fields that you can think about in different HTTP requests. All these things are taken into consideration, right? You can see here as we drill down into one of these entities, the actual user agent, full path. If this was a TLS-based request, there would be a fingerprint here for that. So all these different metadata characteristics are collected and thrown into this fuzzy logic engine. Then we're tracking this, right? Again, that full 90-day window as these different entities are interacting. We're correlating that behavior up together for you. So this risk score that we assign. On the left here, you can see starting out with our most intense entities, working our way down. Now, let's take a look as a starting point at some of the lower risk entities. Now, we did, during the slides, we talked a little bit about the kill chain. If you look here, you can see in the early phases of the kill chain how this risk score is lower, right? So hopefully this is kind of starting to crystallize and put a picture together for you as we are tracking these different entities. Let's just pick a random one here and take a look. In this particular case, I noticed pretty quickly that we've got kind of a non-standard user agent string. So that non-standard user agent string, according to the HackerMind engine here, is getting classified as programmatic access. In and of itself, this is obviously not something that's malicious, but it is something that we want to keep an eye on, right? What is this entity up to now? So in this particular case, a single request, no big deal, right? Let's sort by risk again and look at something moving a little further up the kill chain. So here's one that's moved into the web application mapping phase. You click into here. Now we can see there's actually some interesting behavior going on with this one. In particular, we can see that a single request was blocked. So in addition to ThreatX's risk-based modeling, we're also going to have the ability using analyzers to block any individual malicious request we see. So that's kind of what happened here, is that we can see there was an individual malicious request made. Looks like some directory traversal attempts. We've just gone ahead and blocked that individual request. The key differentiator is going to be that wasn't done using a host of signatures, right? We don't have a vast engine feeding it signatures in the back end with a lot of maintenance and upkeep. This is more of the modern approach where we're using that analyzer technology. Certainly plays into the risk-based blocking as well. A request like that is going to elevate the risk score. Now, it's been a little while since that request was made. A few minutes later, they come back, make this programmatic request, and in this particular case, you can see that the risk score actually drops, right? So this kind of examples there of how the dynamic risk-based approach works and how we're able to look at these different attacker-centric perspectives of who is visiting your web applications and APIs. So one of the really interesting parts is as we move further up the kill chain, we're approaching that risk threshold of 70, where the engine will actually auto block. Even before we do that, though, ThreatX is going to actively engage these different entities. So what we mean by that is, let's say you have a different attacker, or you have an attacker kind of coming through and making a series of malicious requests. Maybe we'll jump in one here and see if we can find a good example to highlight this. As these malicious requests are being made, sorry, a lot of these are blocked. Let's find one here. When these requests are being made, essentially what's going to happen is we're going to begin our interrogation process, right? So this particular process involves initially injecting a tracking cookie to see how that user responds. There's different ways that, based on the different ways that that entity responds to that tracking cookie, we're then going to kind of further move along into the interrogation phase. That's where we're going to start doing some different browser fingerprinting to kind of help understand, is this a bot? Is this a real attacker? And so forth. So that type of interrogation allows us to further understand, and depending on those responses, that's all, of course, fed into the fuzzy logic engine, the HackerMind engine, which is then going to assess and these different risk scores. So now that we have these risk scores and these different entities being tracked, we're kind of focusing down on the most important and elevated attackers in your environment. What can we do with that data, right? In addition to kind of, as I've already talked about, how we're going to auto block after a threshold of 70 is reached. Once that's happened 3 separate times, we will actually blacklist that given entity altogether, right? So if they push far enough, then they're going to be fully blacklisted. At the same time, if we're looking here in the top targets tab, we're going to have the ability to really focus down and help you understand which components of the application these entities are interacting with. So here's a nice example. We can look at all different site data at once. So you can see here all the different URIs, domains, and how they're being attacked, right? Here in this demo environment that we're looking at, we can sort by entities, and you can very quickly see where most of that traffic is focused. If we wanted, again, to look at a larger data set, we can very easily jump in, maybe look at a 7-day view. We jump into our top targets tab again, and you can really start to see where these malicious actors are interacting. Which endpoints are they most commonly interacting with, right? So now if we want to drill down in, we can see here on the search side, /search, what types of requests are we seeing? I really like to talk about sort of the visibility side of ThreatX, and that it just really, we don't abstract away a lot of this useful information. As you can see here right away, any AppSec engineer or analyst is going to quickly kind of notice what's going on, right? You can see these different cross-site scripting attempts, probably more directory traversal in there. So very quickly, we're able to kind of ascertain what these different entities attacking that endpoint are doing. To take that a step further, we can drill directly into that entity if we want to get more information and see exactly what this particular guy was up to. Here were those initial malicious requests. Looks like some cross-site scripting. Now, as you see kind of the way that HackerMind unfolds here and the way that it correlates these entities together, you can start to see how a behavioral-based approach allows us to look for and spot, get eyes on different types of interactions that you simply can't capture with a signature. So different business logic, for example. Maybe you're going to be looking at something that a particular entity or attacker that's interacting with your application in a way that simply isn't common from previous use cases. Now, while ThreatX is not going to employ the very difficult style of baselining an application, right? We don't actually go through and look at every single endpoint and try to understand what is legitimate and what's not for that particular endpoint. Given the rapidly updating nature of applications these days, it's very difficult to keep up with that type of baselining, right? But what we are able to do using the HackerMind engine is kind of understand the outliers, right? So if the behaviors are suspicious, that risk gets elevated, and a combination of those behaviors comes together, and from there, we're able to very easily, kind of see, hey, this is, suspicious. For example, if maybe we look at, let's track down kind of the API here. And if we're looking at this given API, you can see the different entities. You can even see the lower level matches and how they size up, right? So kind of the HackerMind engine picking up on some of the different independent queues that it's tracking, and then here in the number of entities. So I like to sort, by entities first, but it's also nice sometimes to jump towards the bottom and look at some of the outliers, right? So who's coming in, probably here a crawler sort of looking for log data. Nothing too interesting, but it gives you a lot of insight into specifically and exactly how these different attackers are sizing up your applications, which endpoints are of most interest, and so on. Now, really what this boils down to kind of bring it full circle, is that the more context that we take into consideration, the larger, the better our ability is to make better decisions, right? So instead of just making this binary decisions based on binary metadata points, we're going to combine all these different elements together, assign this risk score to the different entities. And now we have a foundation for a very clever way to see these attackers interacting. Again, the interrogation side of things. ThreatX is also going to do some tar pitting, so we'll slow down requests and see how those different bots react to being slowed down. So there's a lot of different clever ways that the ThreatX engine is going to help you understand and essentially correlate behaviors together for you. Okay, so hopefully that gave you some good insight and kind of seeing exactly how ThreatX is able to. We've built this risk-based model, and we can give you these insights into your application security across APIs, across a diverse set of web applications. If you're interested in more information, definitely take the survey. Hit the chat room here on the side and let us know. If you have any questions, we're happy to help with those as well. And yeah, thanks for taking the time to watch the demonstration.